If you, I won't tell the story, it's a bit upsetting, but if you Google problems with independence in courtrooms, you'll hear some very terrible stories. There's one, I'll just tell it. It's a bit upsetting. It is upsetting, right? So there was a case where someone was accused of killing their child, actually both their children. And what happened? The first child had a cat debt, and a few years later, the other one did as well. And the evidence given was that the probability of a cat debt was very, very small. And then they calculated the probability of a cat debt and another cat debt, and they multiplied the probabilities together, and it was small, but it was a tiny, tiny number. And I think the person was convicted on that evidence, but it was completely incorrect because the events are not independent. If you have one child who dies like that, the probability that the second child has some condition that makes it similar is way bigger. And so there can be big errors with this kind of thing. Now we won't go into it, we'll just say they're completely independent, but in more generally you have to be a lot more careful, make sure they can't happen, or rather that you make sure that this happening doesn't affect this one.
Would it be like, say there's two pilots, the first one died, the second one is surely more likely to die because there's no lack of pilot for him?
Well, you can include that, but I would say if the first person died due to food poisoning, or some kind of gas got into the cockpit, or any of these other things, they're not completely independent. Yeah, you can include what you said as well. Yeah. Okay. So suppose the probability, now the way we'll do the reliability of them would be, say, 99.5, so that would be 0.995. 0.995. I know I had the probabilities in the boxes earlier on, but it doesn't really matter. Now, there's an easy way to look at this and a difficult way. So the difficult way would be something like this. If F is the reliability of the flight, so how can the flight pass off successfully?
P1 or P2.
Now, okay, so you say, so one of them lives basically.
Yeah. P1 or
so P1 is okay, or P2 is okay. Now the problem is these can happen at the same time, so we can't just do plus. So what are the different ways?
P1 and P2.
Yeah, so P1 is okay, and P2 is okay,
or P1 or P2. No?
Yeah. So that's one possibility. They're both okay.
Or P1 or P2.
P1 not set. And P2 is okay. Or P1 is okay and P2 knocks it. And none of them can happen at the same time. Now that's not the easy way to do this. Okay? The easy way is instead, what is the probability that it fails, and then take that away from 1. So if, say, there's a 10% chance it fails, the probability that's reliable is 90%. So we're going to do something like this. So instead of actually doing something like that, which is difficult, you'll do the reliability will be 1 minus the probability if it fails. Okay, so you go away and calculate the probability that it actually fails. So, say probability of not the flight. So what do you need to happen for the flight not to work?
2 guys die.
2 guys die. Boy or girl? Or girls. So not P, so I'm going to write not P1 and not P2. Oh, sorry, that not is gone. So the way that you can have not the flight, so the way the flight can fail is the first pilot fails and the second pilot fails. Now we can write down numbers, or we'll write down numbers over here, and then we'll kind of just in between say where the numbers came from. So we'll do the numbers first, because if you can see where it comes from easily, it's okay. Now it's and, so it's multiply. What's the probability that the first pilot fails in living?
0.005.
At 0.005. And what's the probability that the second pilot also knocks it? Same. Now we could do that. The and means multiply. So you're talking probability of not P1 times probability of not P2. And then you could go into where do these numbers come from? Well, the probability of not something is 1 minus the probability of it. So probability of not P1, maybe we'll just write this up here. So probability of not one of the pilots is 1 minus the probability that the pilot does live, which is 1 minus 0.995, which is where your 0.005 comes from. So this number is very, very small, 0.000025, which is, it's very small. So if this is the probability that it crashes, what is the probability that everything is okay? 1 minus that. So if this is the probability that it goes badly, so the probability that it goes okay is 1 minus this. You're fairly safe there. 2 in 10,000. Okay. Now the alternative to setting it up to fail and taking that away from 1 is you use this and actually, looking at this looks, I don't know, I think this is okay. We'll just see, does this give us the same answer? If it doesn't, we're in trouble. So this would be, well, we're not, we're just going to ignore it. This is 0.995. Yeah, this something is in trouble. Oh no, let's see, 0.9. I'm just going to ignore this. It's the safe way. Right.
Is that actual percentage, yeah?
That's a probability. It is a percentage. It's 99.9975%.
That's
So
the
wait,
equation.
That's the probability that there's no problem. Well, no, it's there can be a problem, but
Yeah.
it's okay.
What's PI again there?
PI would be either of the pilots, so not pilot 1 or not pilot 2.
See the notation there on the bottom line there, PA.
This is parallel, so this is same as R. So probably A or B. So this is another way of calculating it. You do 0.995 plus 0.995 take away. So this is like the probability that the first pilot is okay, probability that the second pilot is okay, but you've counted twice that both of them are okay, so you've taken one of them off. But it's nastier. I advise doing it this way. Okay.
That's the probability of not minus fail, is it?
Yes. So not failing is succeeding. So that's the reliability. Okay. Now I'm just going to show that. Well, it's just a remark. So you can use this formula, but I don't advise. I'm just saying they're the same, okay? You see, if you have 3 things in parallel, it's a nightmare because you can have all 3 working, first two, second two, outside two, or the top one, or the middle one, or the third. It's a disaster. So rather than messing around with this other possibility, the A or B working, you're better off just finding what's the probability that it fails. It fails if they all fail, and then take that away from one. So it's saying basically the first regime where, so this is if, so this is the probability of A or B or C working. This is A failing, B failing, C failing. So this is the probability that it fails. Take that away from one, you're done, rather than messing around with this mess. The final extension now is that we're going to have combinations of series and parallel systems. So we're going to have little subsystems. Okay. So right here, a system S consists of 5 identical components connected in parallel. So the block diagram looks like this. Identical components connected in parallel, each with a reliability of A, and that's just saying a number between 0 and 1. A is in the set of numbers between 0 and 1. So it's just, I could actually just leave that out. So A is the reliability. A. So this is an absolute nightmare if you want to do it like directly, because you'd have to say, okay, I'm going to have all of them work. 4 of them work, 3 of them work, 2 of them work, or 1 of them work. That's not the way you're going to look at it. Instead, you're going to look at what is the probability that they all fail, and then take that away from 1. So, what's the question? What's the probability that one of them fails? Just one of them. Now, this A is not. I'm just going to write probability of a fail. So if the probability that it's reliable is A, what's the probability that it fails? 1 minus A. Okay. So for this system to fail, which would be called not S, we need probability of fail and fail and fail and fail and fail. And what do the ands mean? Multiply. So your probability of fail by probability of fail by probability of fail 5 times. So if you have 5 things multiplied together, what would you write? Power of 5. So you got probability of fail to the power of 5. And what's the probability of a fail? Of one of them failing? 1 minus A, so you have 1 minus A to the power of 5. So this is the probability that the system fails. So the first one fails, the second one fails, the third one fails, the fourth one fails, and the fifth one fails. A stupid context would be 5 pilots. They'd all have to die for this not to work. Now this is the probability that it fails. So what would be the probability that it works, that it's reliable? So this is the probability that this system fails. What is the probability that it works?
Oh, is it that?
1 minus.
Yeah, 1 minus is how you say opposite. So now there's lots of notation there, you don't really need it, it's right here. Therefore the probability of it not failing, i.e. succeeding and being reliable, is 1 minus this. Okay. The other question there is find A if the overall reliability is 0.96. So this is the system reliability. So I want to find out the value of A if this is equal to 0.96. So we have a little equation to solve. Now, I think we had equations arise in the matrices, but I said not to worry too much about them. They were like, those quadratic equations, but a more general equation like this is fair game. So you're supposed to be able to solve the equation. I suppose you can do them a little bit from your other modules, but we'll just kind of give you the strategy here. What do you want to find here?
A, is it?
A, right? So what you do is just look at things that aren't A and get rid of them. So looking at this, forget about this. What's in the way? What's stopping A from being on its own? The 1. How do you get rid of this plus 1? Minus it. So take away 1 from both sides. I'll just write it down here. So you're taking away 1 from both sides. So you'll be left with minus 1 minus a to the 5. Take away 1 here, you'll have minus 0.04. Remember, you're looking for a on its own. What's in the way? What's annoying you? What's in the way? Change of signs. Have you a good way of doing that? Multiply both sides by minus 1. What's in the way now? Power of 5. Now what's the, how do you get rid of the power of 5? The fifth root, yeah. So the fifth root. So do the fifth root of both sides. If it was squared, you do the square root. Cubed, you do the cube root, the fifth root. Both sides. That will get rid of the power of 5, and you've got 1 minus a is equal to the fifth root of 0.04. Ultimately, that's just the number on your calculator. We'll get it a little bit later. Actually, we'll get it now. So this is approximately, you'll use 4 significant figures. So 5253. So I have 1 minus a is equal to 0.5253. Now, some of us, now once you get to here, I'm happy enough. So there's different things you want to do, different things you can do. Okay, what's in the way of a being on its own? The 1, how do you get rid of the 1? Take away 1 from both sides. So you'll end up with a is equal to minus a is equal to minus 0.4747, and then you can do the same trick from above, multiply both sides by minus 1. A is equal to 0.4747. So I suppose the lesson there is, if you have enough backups, all the backups on their own can be pretty crap. They only work half the time, and it still allowed the overall reliability to be as high as 96%. That's the question there. Any questions on that? Okay. Look at the next one. This RBD stands for reliability block diagram. So consider the reliability block diagram that's described by the diagram below. Probability of A, so the reliability of A is 0.9, B is 0.8, and C is 0.7. Compute the system reliability showing all steps and blah 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 blah. So what you do with something like this is you split it up. And take A to be just the first part of the system, say system 1, and take this to be the second part of the system. Because what you need is the first system to work and the second system to work, because they're in series. So you need A to work and B or C to work. So so the system reliability, or I seem to have called them C1 below, C1, C2. For the system to be reliable, we need the first component and the second component to work. So the system reliability, we'll call the system overall S. For this to be reliable, we need the first one to be reliable and the second component to be reliable. What does and mean? Multiply. So the reliability of the system overall is the reliability of the component 1 multiplied by the reliability of component 2. The first part is easy, it's just the reliability of A, which is 0.9, and then you have to have a think about the second one. So what you're going to do here is you're going to focus on the probability of it failing. So the probability of not C2 how can C2 fail?
B
and C both fail. So for the second component to fail, you need B to fail and C to fail. So this is the same as the probability of not B. So B fails